All right, still talking about conics, or the sections that can be sliced from cones. We are now talking about ellipses. So the set of all points in a plane such that the sum of the distances from the two fixed points is fixed is called an ellipse. So the best way I have to describe this is if you had two nails with one string between them, but there was some slack in the string, and then you put your pen inside the string and pulled it tight, everywhere you could draw would be an ellipse. You could go outside both of these black points, and you would create what's called an ellipse. Something like this. The planet's orbits are ellipses. Ellipses, it's often not depicted very well. They look like they might be circles, but they're actually ellipses. So the sun is usually back at this end, and then the planet goes farther from and closer to the sun as the year goes on. There's a lot of vocab with ellipses, so we'll go slowly through this. I would encourage you to take some careful notes about what these are. Once you kind of get an idea of what they are, what these different terms are, and what they represent, and how those things interact with each other, it's really not as complicated as it looks. But I know that this picture looks terrifying. So the two fixed points, the nails that are holding the string down, are called the foci. It's the plural of focus. So each of those points is a focus. Together they are called foci. Every ellipse has two axes of symmetry, a major axis and a minor axis. The major one is longer, the minor axis is shorter. If they were the same length, they would be diameters and it would be a circle. So by stretching one of those axes out, we create an ellipse. The axes are perpendicular to one another and they intersect at the center of the ellipse. So where they cross is the center. The foci of the ellipse are always on the major axis, the longer one. The endpoints of the major axis, meaning where it intersects the ellipse itself, are called the vertices. Each intersection is a vertex. And the endpoints of the minor axis are the co-vertices, or co-vertexes. Okay, so let's look at just half of this picture. So this is the same picture twice, just a vertical ellipse and a horizontal ellipse. Let's look at just the horizontal one. Okay, we have a center in the middle. These 2 points labeled F are the foci. They're on the major axis, and they're the fixed points that relate the string, if you will, to the ellipse. The vertices, the vertexes, are the points on the major axis, the longer one, where they intercept the ellipse. And then those interception points on the shorter axis, the minor axis, are the co-vertices. Okay, you'll see there's a little right triangle in here, A, B, C, and that's going to come in handy in a little bit. Take a second and pause this if you need any of this in your notes, if you want to draw this picture or whatever. I'm going to keep moving, but we're going to keep probably flipping back to this as the video goes on. So here is the equation for an ellipse whose center is the origin. Later on, we'll talk about an ellipse that is moved, but for now, an ellipse whose center is the origin looks like this. X squared over a squared plus y squared over b squared equals 1. That's horizontal. If we swap x and y but keep a and b the same, then it becomes vertical. We'll talk more about that in a little bit. The foci, right, those are the points on the major axis that define the ellipse, are at C0 and negative C0. So if we go back here, you'll see that C is the distance from the center to the focus. So if you go that distance left, it's negative C, and if you go that distance right, it's positive C. The length of the major axis is 2a. So this is a right here. It's the distance from the focus to the co-vertex. Okay, so double that length is the length of the major axis. The minor axis is 2b units. B would be this guy from the center to the co-vertex. So the minor axis is 2 times b. The major axis, this length, is 2 times a. All right, the sum of the distances from the foci to any given point on the ellipse, the constant sum must be greater than the distance between the foci, which makes sense, because if I pulled this string tight between F and I tried to move it, it wouldn't go anywhere. So it has to be longer than just that distance. So let's go through one. We want to write an equation for an ellipse. I threw the standard form up here. We're going from the picture over here. So the first thing we have to do is find the center. So all we have are the two foci at 0, 7 and 0, -7, and the vertices at 0, 9 and 0, -9. The foci are always equidistant from the center of the ellipse. Okay, so if we just find the midpoint between 0, 7 and 0, -7, we will have the center of our ellipse. So the midpoint is easy. We're just going to use the midpoint formula. Right, so 0 plus 0 over 2 for x, and 7 plus -7 over 2 for y. Well, the first one's going to be 0. 7 plus -7 is 0 divided by 2, still 0. So the center is at 0, 0. Perfect. We're going to find the value of a. The vertices are from 0, 9. Oops, let me not cross that out. 0, 9 to 0, -9. Remember we said that the length of the major axis is 2 times a. Okay, so I want to find just a. So if the length of the major axis goes from 9 to -9, that would be a length of 18, right? But that's 2 times a. So divide that in half. A is 9, and a squared is 81, which is helpful because that's this number. So that's going to be 81. Now we need to find the value of b. We don't know where these 2 points are, so I can't just figure that out by counting squares. However, I do have the Pythagorean theorem. C squared equals a squared plus b squared. If I go back to my picture, you can see this triangle right here is a right triangle because we know that the axes are always perpendicular at the center. A is this length, C is from the focus to the center, and this is the one we don't know. Okay, so the focus to the center is 7 units, so C is 7, so C squared will be 49. A squared, we already figured out, is 81, and then we solve for b squared. So I subtract 81, divide both by a -1 to get it positive. B squared is 32. I don't care what b is, because I want b squared, and that's going to be 32. Okay, so because the major axis is vertical, a squared goes with y, because if we go back here, for a vertical one, a squared and y squared go together, b squared and x squared go together. So what I was writing at the top up here is actually incorrect. Well, no, I'm not. I guess I had y squared first, so that does work. So y squared goes with a squared, so y squared over 81 plus x squared over 32, and it always equals 1. Okay, so I know that seems like there's a lot going on there, but if you break it down into these steps, it's not too bad. I would go ahead and make notes about these steps, find the center, find the value of a, find the value of b, and then just plug it in. The only decision you have to make for writing the equation is whether the major axis is vertical or horizontal. If it's horizontal, it's x squared over a squared plus y squared over b squared. The easy way to think about it, wherever the major axis is, in this case the major axis, the longer one, was vertical, so the longer one, 81, goes with the vertical dimension. That's just how that's working. Okay. So, like I said, pause this and take notes if you want to. I'm going to keep moving. So if we move the center from 0, 0, we need to throw an h and k in there. Okay. So we've got x minus h and y minus k. It's exactly the same, it's just the horizontal version where it's y over a and x over b. That changes the location of the foci, vertices, and co-vertices just a little bit. We're adding h to the x coordinates and k to the y coordinates. Okay, so I'll give you a second to copy that down. The foci are at h plus or minus c plus k, plus or minus just because if you're going, left or right to the focus. Notice in the vertical one, it's k plus or minus c because we're going up or down, just like in the example we just did. Vertices are going to be at h plus or minus a and k, or h and k plus or minus a if it's vertical. This is exactly the same, it's just that these h's and k's used to be zeros when the center was at 0, 0. It's just not anymore. Okay, so we can use this information to determine the equations for ellipses. The original ellipse at right is horizontal and has a major axis of 10 units. We can tell because we're going from 5 to 5, that's 10. So a is 5. That means a squared is 25. The length of the minor axis is 3. Or sorry, is 6, because that's 3 and that's 3. So b is 3, so b squared is 36. Is 9, not 36, 9. We got to cut it in half. That's my fault. B is 3, we square that, it's 9. So the ellipse is translated 4 units right and 5 units down. So h is 4, k is negative 5. Okay, it's horizontal, so the longer axis goes with x. So x over 25, y over 9. And then I just need to throw in my h and k, and we're done. We're going to do one more example together with a center not at 0, 0. Write an equation for the ellipse with vertices at 6, negative 8, and 6, 4, and co-vertices at 3, negative 2, and 9, negative 2. The x-coordinate is the same for both vertices, right? So these are the vertices. X is the same, so I know that the ellipse is vertical. Now I know the vertices are on the major axis, right? Because if it's the minor axis, they're called co-vertices. The center of the ellipse will be at the midpoint of these two. So if I just use the midpoint formula, 6 plus 6 over 2, negative 8 plus 4 over 2, this is the center. The length of the major axis is going to be from negative 8 to 4, so 12. Cut that in half, we get 6, so a squared is 36. The length of the minor axis is going to be from 3 to 9, right? Because these are the same, so that doesn't make sense. It'd have to be from 3 to 9. Or 6 units, cut that in half. B is 3, so b squared is 9. So then I can start writing it. It is vertical. That means that y goes over the longer axis, the major axis. So y over 36, which is a squared, x over 9, b squared. And then I just need to throw in the coordinates of my center, 6 and negative 2. So y plus 2 and x minus 6. This is the x-coordinate. That's the y-coordinate. So they have to go with x and y respectively. And there is our equation. As always, please feel free to shoot me an email or get a hold of me with any questions. I hope you have a great day, and good luck with the homework.